Hello and welcome to the exam 2 review sheet. In this review sheet, I'm going to cover the main concepts that we've encountered in the last section. After the first exam. So this will include measurement reliability and validity, some survey research basics, sampling, and external validity. So let's start with the basics of scales of measurement. You might recall that Stevens scales of measurement, which are often taught in almost every stats course and research methods course in psychology and beyond. They were an attempt to make psychology a more scientific discipline in order to understand measurement better. So, I mean, basically, a science is only as good as the measures that it is founded upon, and historically, like very historically, the measures in psychology were at some point non-existent or completely qualitative, uh, or just kind of just not the greatest. So Stevens came along and said, well, let's at least categorize. Let's create um, a a category system for variables. So he came up with nominal, ordinal, interval, and ratio. So nominal variables are simply names, variables that just have a name. So like the name, your name is if we were to collect data on everyone's name in a sample, that would be a nominal variable. Another example of a nominal variable could be something like the name of the airline that you last flew on, or the number on a baseball jersey. That is actually a nominal variable because it's basically just a label or a name or an identifier that has no quantity involved in it, no quantification involved in it whatsoever, usually. Ordinal variables, on the other hand, are ranks, so rank ordered data, so finishing position in a race or something like that. Interval variables are typically more or less continuous variables where the intervals between equally distant points on the scale have the same underlying difference in terms of the construct that's being measured. So something like a temperature scale is an interval measure where the difference between 10 degrees and 20 degrees is the same as the difference between 90 degrees and 100 degrees. Now subjectively that may not be true, it may not feel true, but a ratio variable is the one with the most information, because not only does it provide a quantification, it also allows for you to do more with it in terms of like making claims regarding the ratio, like something's twice as much as something else. And the reason for that is that a ratio variable, and the major difference between an interval and a ratio variable is a ratio variable has an absolute 0 point, meaning that there is a point that means that there's absolutely nothing of the variable in question. Now that it doesn't have to be possible for there to be none or nothing, but it just has to be on the scale. It has to have meaning as absolute zero on the scale. So some examples of this might be the number of cigarettes you smoked today. Presumably you smoked 0 cigarettes today, so and that is an absolute zero. Or how many books have you read in the last month? So there's an absolute zero on that scale. How much do you weigh? There's an absolute zero on that scale. Obviously, it's not possible for you to weigh zero, but because zero is part of the scale, it will allow you to make statements regarding, like, okay, 40 pounds is twice as much as 20 pounds, and 200 pounds is twice as much as 100 pounds, and statements like that. So the ratio variables have the most information and can more can be done with them statistically. One issue in psychology is that a lot of variables, especially of the self-report variety, can be considered none of these. So, for instance, a self-esteem scale. If you were to go online and Google Rosenberg self-esteem scale, you can go ahead and take it. It'll give you a score. So, what's the score on that? What does it mean? Is it interval? Is the difference between a self-esteem of 10 and 12 the same as the difference between a self-esteem of 20 and 22? And so the answer to that is maybe, I don't know. So what many researchers or what many books or sources will call those sorts of self-report psychological scales are approximately interval. So it's not quite interval, but we don't want to treat it as ordinal or nominal because that would make the statistics we need to do kind of silly and kind of complicated unnecessarily, and would probably give us the same answer as if we treated it as an interval variable. So we'll call those sorts of things approximately interval. Moving on to the reliability of a measure. Remember, the reliability of a measure really is about how error-free, or I don't want to say error-free, but what proportion of the total variance in a measure or variable is true score of that variable, and what proportion is error variance. Another way to think about reliability is consistency, and related to that is test-retest reliability. So test-retest reliability is simply you administer the measure, you wait a certain period of time depending on the measure. Too. The same group of people are taking it twice, and presumably you'll have a strong correlation, like 0.6, 0.7, 0.8, some 0.9. Let's go nuts, but right? But it doesn't always happen, and sometimes it's because the variables are not meant to be stable. The variable is not meant to be stable. So something like a measure of mood, we don't expect a high test-retest reliability unless we're measuring it like within the same half hour or same 20 minutes or something like that. Uh, Another thing to take into account is the extent to which you expect the value to actually change. So if it's something like personality and you're measuring it across a decade, there's going to be some change. And that brings to another thing that matters is the amount of time that has passed. So if you demonstrate a really stable correlation in personality across a week, it's probably nothing to write home about. If you measure a personality trait over the course of a decade and you find that, okay, there's a moderately strong and significant correlation between these two variables, then go ahead, write home about it. Moving on, another type of reliability that we discussed is internal consistency reliability. Internal consistency reliability has several subtypes, but they all kind of get at the extent to which a multi-item scale more or less hangs together or intercorrelates within the items that are part of that scale. So there are a bunch of items, let's say, that are intended to measure, let's say, extroversion. Those items, if they're measuring the same thing, they should be all related. So we'd want to check the internal consistency to verify that that is indeed the case. So various forms of internal consistency reliability exist. Probably the most popular is still Cronbach's alpha. Cronbach's alpha should really range from 0, meaning that there's no relationship between the items in the scale, to 1, meaning there's a perfect relationship between the items in the scale. You'll never see either of those values in the wild. We typically want to see a Cronbach's alpha above 0.7. 0.7 is usually considered acceptable. 0.8 is usually considered good, and 0.9 and above is considered excellent. So that's one way to gauge the reliability of your measures. Wouldn't want to use measures that have low reliability because then you're going to just have a lot of error and noise in your study and you may not be able to detect what it is that you intend to detect. Another type of way to look at reliability is to simply assess the inter-item correlation matrix. And that's just simply a correlation matrix where we're correlating the items with each other. So let's say there were 10 items measuring extroversion. We'd have a table with the 10 items across the top, 10 items across the side, and we would look at, okay, how do these items correlate with each other? You don't want, if they're supposed to be measuring the same thing, you usually don't want the correlation to be very low. I mean, maybe the lowest you'd accept is if some items are correlated like 0.3. Certainly that's not ideal, but it can be worked with. But below 0.3, it might become a problem where some of the items are simply not a good measure of the construct that we have in mind, or the variable that we have in mind. Moving on to item total correlation. Item total correlation is simply, as it might sound, the correlation between an item and the total score on a scale or test, if you will. So if you were looking at your correlation items and you see an item total correlation for item 1 of 0.77, you're probably going to be like, all right, that's pretty good, that's pretty strong, let's keep that going. If you look at it and you see a correlation of 0.11 or something like that, you're probably going to say, oh, that's not the greatest correlation between these items. Maybe they're not measuring the same thing. Relatedly, there is a type of item total correlation called corrected item total correlation. So corrected item total correlation is when you take out the item that you're focusing on. So you're going to go item by item to look at these item total correlations. But in a corrected item total correlation, you're going to take out the variable that you're assessing and just look at how that variable relates to the remainder of the test, right? Where item total is how that variable relates to the entirety of the test. Corrected item total is how that item relates to the remainder of the test, less that particular item. So moving on to validity, validity, as you might recall, it can be defined in a couple ways. The most common way is the validity measurement validity, because there's various types of validity. I should clarify. Measurement validity is basically the extent to which a measure assesses what it intends to assess. In other words, the extent to which the operational definition of the measure matches the actual conceptual definition or theoretical definition of what the measure actually is. So one example I like to use is for depression. If you just show someone a depressed mood scale, they might decide, oh yeah, that's an adequate measure of depression, but in reality there are multiple components or aspects or criteria for depression. So if you just measured one of them, you may not have the most valid measure in the world. So that brings us to content validity. Content validity is, you may recall that we mentioned face validity. So face validity by many serious, let's say, psychometricians or researchers is generally kind of frowned upon. It's a non-scientific kind of simple way to assess whether or not a measure is valid, because that's simply looking at the measure and just deciding, okay, that sounds like it measures what I want it to measure. And of course, there's always that point. You're at that point usually if you're writing items and developing measures, you're usually kind of just using face validity at first. But you might kick it up a notch and do something called content validity, where content validity is basically like uh, face validity done right. So you find experts, presume maybe even become an expert on the topic, and you have these experts rate each item on the extent to which they feel that the item measures the construct is an important part of the scale, or on the flip side, they might help to identify items that don't belong in the scale. One way they do this is to assess to make sure that there is not over-representation of the construct, meaning we've gone beyond the construct and started measuring things that aren't directly related. We also want to make sure there is an under-representation, as I said before, because you don't want to make sure you miss an important part of what it is you're supposed to be measuring. A cool type of validity, I think, when you can demonstrate it, is criterion validity. Does this measure that, let's say, someone's developed or you've developed, and you want to see, is it predicting what it should predict? So you find a criterion. So for example, many years ago, a self-monitoring orientation scale was developed. And part of that process was checking the criterion validity. So self-monitoring is basically the extent to which you think about your own behavior and adjust your own behavior to mold in with the environment. So people on the extreme end of this, the high end, they're more or less like social chameleons where they can act in certain ways based on who they're surrounded with. And the people on the low end of self-monitoring orientation would be kind of they are how they are no matter where they go. They're not going to change their, demeanor or personality or behavior. They're going to stay the way they are. So, getting to criterion validity, how does that relate to criterion validity? When that scale was developed, one way that it was developed was to see, does it predict things that it should indeed predict? Like, for instance, an actor should have higher levels of self-monitoring orientation than, let's say, someone in the chess club or something like that. Let's think of another example. So, many employers will give you a pre-employment screening questionnaire. Assuming that was developed by psychometricians or by people who are, well aware of the statistical methods to develop such a test, they likely used criterion validity, where they gave it to a subset of employees, perhaps when they first signed up, and then they waited until they had enough of that subset, a large enough of that subset, and then they tested the correlation between, let's say, the score on the pre-employment screener and some important outcome, like, let's say, number of times one was tardy, or the number of times somebody called out, or how many disciplinary actions somebody had. So if they can find that a test or scale predicts even a little bit of variance in an important outcome, it can make a lot of money for the company, in particular, by selecting more productive, let's say, employees. We can divide criterion validity into concurrent and predictive. Predictive is simply when the predictor or the measure is measured first or assessed first, and then over time it's kind of like a longitudinal setup. We check on things again, and we measure it. In the future. So that's predictive as a time component. Concurrent is when we more or less measure the criterion and the measure at the same time. So let's say we were doing a study on anger management, and we developed a scale. We would want to then see if we can provoke people who score high on the scale more so than people who score low on the scale. And in order to do that, we'd do it more or less at the same time. We'd give them the scale, and then we'd call them into the lab and like have some kind of elaborate cover story and try to see, can they be easily provoked. And so, criterion validity concurrent is when the measurement and the thing it's supposed to predict, the criterion, are measured more or less simultaneously or at the same time. Construct validity, actually, more modern thought kind of calls all of these types of validity construct validity, and still identifies the subtypes, but considers them as a subtype. So construct validity is usually assessed based on the relationship between your measures and things that it should be related to and things that it should not be related to. So, for instance, if you're developing a measure of, let's say, school pride at UTRGV, you might want to make sure that it is distinct from some other measure that someone might claim is the same thing by a different name. Uh, on the other hand, discriminant validity is when you want to establish that your variable of interest is reasonably independent, or the measure, the variable that you're developing, is reasonably, maybe independent is too strong a word, but we want to make sure that it's not too strongly correlated with other things, because if it is too strongly correlated with other things, it may just be that thing by a new name, right? So you may have not have come up with a new measure, you just rebranded, repackaged, recycled an existing measure. In the slides, there's a bunch of principles for good survey writing. You should review those somewhat thoroughly, but a lot of them boil down to keep it simple. Keep it easy to complete the survey. Don't make it unnecessarily complex. Don't ask double-barreled questions. Don't ask leading or loaded questions. Don't tip the scales or put your thumb on the scale, so to speak. Make sure that you proofread your scale and test your scale out assuming you were developing a scale, you'd want to test it out uh, not only on your sample for your scale development study, but you'd also want to test it out on friends and family or anyone willing to look at it to help you spot some issues with it. Because working on a scale from scratch for the first time, it kind of seems like a simple thing because a lot of those research papers are quite short, but the amount of time and effort to collect the data and analyze the data and write up the data is enormous. So um, you should review the principles of writing good survey items more carefully and let me know if you have any questions or further questions about the topic. Related to survey research is the issue, although this is an issue in almost all research involving humans, is the issue of social desirability responding. So what that means is somebody just responding in a way that is socially desirable for whatever reason. People will do this on an anonymous survey where we'll tell them there's no chance anyone will ever know that you completed a survey. They're still like, nope, not going to trust it. We're gonna treat it as if someone's going to read this and know who I am, right? And when you see social desirability responding, it's usually just like they're making themselves look more positive, or they're trying to give the not the participant, the experimenter or researcher what they want to see, just to please them. So that's generally a bad thing if your study has high social desirability responding. Uh, Another issue that kind of plagues survey research, especially in modern times, is non-response bias. So a lot of times you might sample someone from a sampling frame, which is just sampling frame is just simply a list or spreadsheet of everyone in the population of interest that you can attempt to sample from. So um, you might see that some people don't show up, right? And maybe the people who show up are different from the people who do show up. So we'll call that a non-response bias. So if there's a difference between the people who have completed the study and the people who dropped out or just never showed up, it kind of is a problem because we were not able to really answer the question we wanted to answer, and we weren't really able to thoroughly pilot the test that we want to pilot. So looking at the different methods or modes that we can administer a survey, we can administer an electronic survey, which basically means through the internet. I guess at one time there were other options like I don't know, administer it through I don't know, a program or something. So this is really just internet. Has become rapidly the most commonly used form of distributing surveys, especially since the survey software has become slightly more user friendly and accessible. And the one that a lot of people seem to have nowadays is called Qualtrics, where you can set up a survey rather quickly. For the purposes of this class, I won't be able to get you access to Qualtrics, but you can use a program called SPSS, or you can use JASP. Both of those should be freely available to you. There's also R and some other, sources that you can use to conduct your analysis. So uh, moving on to interviews. Interviews can be great, but they can be expensive and time consuming. But the one advantage to that is that you do have time to clarify any issues that the participants might have. Like if they don't understand a question or their pen goes dry or something like that, you're there to help them out during the interview. Interviews can be quantitative, however, they're often qualitative, where they may have some mixed methods uh, aspect to it. Once upon a time, there was such a thing called a group interview, or I should say, group survey, where the survey was distributed to a large group, let's say in a classroom that was assembled to take it for extra credit or whatever like that. And the group has the advantage of people who really want to ask a question or need clarification can. It's probably not as convenient for them to do so as if you had done it in a one-on-one setting, but it solves the problem of getting a ton of data or a good amount of data at once while also being there to answer questions in case they arise. So moving on to telephone surveys, until somewhat recently, like once everyone had a smartphone in their pocket and it tells you the number that is called, and I even have a spam button or a screen call button on my phone, they've become more difficult to accomplish. But once upon a time, there was a thing that was used kind of regularly called random digit dialing. It was basically the phone or the computer hooked up to the phone would randomly call numbers, like completely at random, until you connected with the, uh, the sample that you needed. So that's the sample that you need uh, from a random digit dialing sample. Let's say a telephone sample that's random digit dialing as opposed to just cold calling, whoever your friend, your aunt, your cousin, whatever. The telephone random digit dialing would randomly call up people. So the samples generated were usually, although not always, were usually much more representative of the population than if you had done a a uh, a non-probability sample, like a convenience or purposive sample. And then finally, but we can't forget that there is such a thing called mail, and surveys can be mailed to people. In fact, I've received a few in the mail in my time. I think the most memorable I've told you about already was the Nielsen's when they wanted me to keep track of everything I was watching on TV. And then also it came with the crispest $5 bill I'd ever received. It was almost like they have a printer where they can print these beautiful new dollar bills. Okay, sampling is, it could be a topic in and of itself. In fact, in statistics, in many statistics departments, probably in our own, there's an entire, when I say our own, I mean the one at UTRGV, there's an entire course that you can take on sampling. And there's people that specialize in this. So it's not like we're going to become all smart reading just one chunk of one chapter on the topic, but we should get the basics down. So we should know that non-probability sampling is, as it sounds, any method of sampling that doesn't involve attempting to introduce some element of randomness so that we can hopefully get a sample that is representative of the population, which would in turn allow us to generalize the results back to the population. In a non-probability sample, let's say, most common might be a convenience sample. So a convenience sample is simply you just take what you can get pretty much. You might have inclusion or exclusion criteria, but you're basically sampling what's convenient to you. So students in the intro class is a classic, you know, convenience sample. Or maybe just passersby at a mall or shopping center or park. That would be a convenience sample. Heavily used in psychology. Probably not the best type of sample, definitely not the best type of sample to use from a standpoint of being able to generalize results, but certainly an important type of sampling that you should be aware of. Probability sampling, on the other hand, uses methods, usually random selection methods, although it can get much more complicated, to measure to assess what am I trying to say? To ensure to some extent that the sample itself is representative of the population and the results can generalize back to the population. So simple random and stratified random. Simple is just you're selecting at random from the population and you're hoping that more or less the demographics of the people that you sample are similar to the population of interest that you're trying to generalize your results to. On the other hand, stratified random sampling is when there may be certain strata that you want to make sure that you stick to certain let's say percentages. So you might say, okay, I know that there are, you know, 50% female and 50% male in the population. So I'm going to use stratified random sampling. Let's say I have a list of 50 males and a list of 50 females. I use stratified random sampling to randomly sample within those clusters. You can almost think of it as different samples that are part of the same study. And that also can allow you to have a sample that is representative of the population, which in turn will allow you to generalize your results back to the population of interest. All right, moving on to quota sampling. This is a non-probability type of sampling where let's say you know that the population is 30%, let's say 30% Republican and 70% or 65% uh, 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 Democrat, and then maybe there's like whatever's left over is other or independent or something like that. So let's say you want to make sure you have a good cross section of all those. You'd you'd predetermine first, determine what the percentages are. I was just making those up before. I have no idea what they are, where we are, or in any other place really. I don't have that committed to memory. But you would make sure that you met the quotas so that you had a sample in the end that was more or less it's not as good to use as probability sample, but more or less you can kind of ensure that using quotas, let's say for the number of you know juniors, seniors, and freshmen in your study, or the number of white people, black people, or Hispanic people in your study, using those quotas can help to create a more diverse and hopefully more generalizable set of results. Okay, moving on to purposive sampling. Purposive sampling is when you want to sample a particular demographic that if you use some other of these methods, you're not likely to find them very often. So let's say like people who have been to space. Let's say that's your sample, your population that you're interested in. You're certainly going to use a purposive sample because there's not that many people, first of all. And second of all, if you develop a survey, another method to send out, to try to get them into your study. Let's say just like a simple flyer or call them and say, hey, you've been selected for this study through a random process. They might tell you to go to hell. But through purposive sampling, you seek out a particular group that you're interested in. So it could be anything really, like veterans, priests, people who drive motorcycles, and whatever the study is supposed to be about, you would deliberately seek out a sample that matches the characteristics that you're looking for. Finally, complex sampling is like this is where it's like the math gets mind-boggling, and even doing it in SPSS for the first time might take some blood, sweat, and tears out of you. However, complex sampling is kind of combining different sampling methods, and you're probably going to want to hopefully have access to a sampling specialist or a statistician who knows quite a lot about this stuff. So, complex sampling is usually combining several sampling types to hopefully yield a more representative sample. Now, some researchers will apply sampling weights so that, let's say, if white people are overrepresented in the sample, they'll be weighted. Each individual white person will have their data weighted less heavily than if it was a city that, let's say, had 70% white people in your sample. Let's say it was only 50% white people. You would weight the white people in your sample more heavily so that hopefully the results would be more more similar to the population of interest, the demographics of the population of interest. Okay, finally, external validity refers to the extent to which the findings of a given study can be generalized to different persons, places, times, and even other instantiations or operational definitions of the variables. So we want to be able to hopefully generalize our results. What's the best way to do that? Probably to get a probability sample of some sort, simple random sample, or a stratified sample. The trouble is, especially with human participants, it doesn't always work because there may be some people who just don't want to participate and they hang up the phone or they don't look at your email even though they were selected. So in these types of research where you know the participants are being recruited, it's important to have some sort of incentive it's also important to have some sort of attention check to see if they're paying attention. So the surveys that I do, more recently, these are surveys with students, and some of them may not pay complete attention and may click through. So I try to have some items in there that are attention check items to see are they paying attention, right? So in any case, external validity is the extent to which the findings might generalize to different places, times, people, or even other operational definitions of the variables. Because some variables may have multiple operational definitions, and if, let's say you do a study using one operational definition of your conceptual variable, let's say one measure of depression, then you do another study, and for whatever reason you use a different measure or you tack on another measure, the extent to which the findings generalize to those different measures, operational definitions, or instantiations of the variable, the more confident you can be about how generalizable the results are, or in other words, how externally valid the results are. So how do we address external validity with a probability sampling? Well, that's easy. Probability sampling is designed to really make sure that the sample is representative of the population, and to the extent that it is, and you have findings with a probability sample, you probably have a pretty solid case that those results would generalize. It's not a given, it's not and nothing's a given in science, because you might have found something just by chance in your probability sampling, right? That's why we take into account in statistics not only the effect, but also the noise or the potential error, sampling error, that could be present in our data. How do we address, though, the harder question is how to address external validity or generalizability if you have a convenience sample? And the answer to that is to use different convenience samples in hopefully a diverse set of groups. So, I'm trying to run a study where I'm going to collect data here down in South Texas. I'm also going to attempt to collect data in, up north, let's say in Chicago or something like that. Now, if I find something here in South Texas and it replicates in Chicago, I'm going to have more confidence that there's external validity, that I can generalize the findings. If I run a study here and it doesn't replicate in Chicago, it might be, okay, that the effect isn't real, it doesn't generalize, or it's super specific to the population here, or it could just be a fluke thing where one of the studies worked by chance or one of the studies didn't work by chance. So things can get pretty complicated. I don't mean to make this sound like this is all easy, cheesy, pumpkin peasy, but this is the basics of what I want you to focus on for exam number 2. And exam number 2 will be largely multiple choice questions about this content. However, I will ask one or two short essay questions. And in those short essay questions, I am likely to ask you about sampling and how sampling can relate to the ability to uh, have strong external validity and, in other words, generalizability of the results. But I'll also ask you, like how can we deal with external validity in experiments? So let's say we're running experiments where we really can't randomly sample from a population if it's with human participants. How can we address external validity in non-probability samples and convenience samples and other types of samples? So those will be the essay questions that will be on the exam. So if you made it this far through it, congratulations, you now have the essay questions. I hope you have a wonderful day, morning, night, or whatever time it is when you're listening to this. And that's all I have to say really for now. If you have any questions or concerns, feel free to reach out to me by email, and I will do my best to get back to you as soon as possible. I will not, be, burning the midnight oil uh, on the night of the exam. So if you're going to have questions, you should send them sooner rather than later. Don't expect me to just be sitting by my computer, all day, every day for the rest of my life. But to be honest, it kind of feels like the last 2 years. That's what I've been doing. So I'm looking forward to not doing that for a while, someday soon. And in any case, you have a good night, day, morning, and take care.